Exercise 7b, exact values and Pythagorean relationships. Alright, here we go. Identities. We got the main identity. Sine squared plus cos squared equals 1. Okay, from this identity we can actually get two more identities. Okay, and the way to do that is to just divide each of these things by, let's start off with dividing them all by the same thing. Okay, cos squared theta. If we divide them all, then we get sine squared over cos squared is tan squared plus cos squared over cos squared is 1. And 1 over cos squared, that is secant squared. Okay, so that's our first identity. Have a guess what we divide all these three by to get a different identity. If you guessed sine squared, you were correct. Okay, we divide these all by sine, we get 1. The first one, we get, okay, what do you think? Cos squared over sine squared. Did you guess cotangent? If you did, you were correct. 1 over sine squared, that is cosecant squared. Okay, so we got, from one identity, we get two more. So we got 3 identities. Okay, and then just exact values for your special triangles. Okay, you need to know your special triangles. Alright, well, let's have a look at some examples. Okay, find the exact value of cosecant 2 pi over 3. Alright, we know it's going to be 1 over sine 2 pi over 3, because that's what cosecant means. Alright, and then, well, sorry, okay, this is in quadrant 2. Okay, 2 pi over 3, so we need to write this angle as pi minus theta. So, we write this as 1 over sine of pi minus, and so this new angle here is going to, of course, be pi over 3. A base angle, if you will. Alright, so this is stuff that we're doing in Maths B. It's just using the fact that, okay, this is going to be, I can drop the pi minus, make it pi over 3, and then I just have to decide, is it plus or minus here? Okay, it's sine. I'm in quadrant 2, sine is positive. Okay, so it's just that. So now I can use my special triangle. Sine of pi over 3, sine is O over H. So we've got square root 3 over 2. So we've got 1 over square root 3 over 2. And of course that is 2 over square root 3. Okay, done. That is cosecant of 2 pi over 3. Alright, next example. Exact value of this messy looking thing. Alright, we're going to times and a plus. Alright, let's just go through one at a time. So this first one, secant, okay, secant is 1 over cos, pi over 6. Alright, times. Cosecant is 1 over sine, 5 pi over 4. And we're plussing cotangent is 1 over tangent of negative 2 pi over 3. Alright, so now I need to start going through these ones. Alright, so first one is in quadrant 1, so we're in quadrant 1, so we can just use our special triangle. Cos of pi over 6, that is adjacent over hypotenuse, so that's square root 3 over 2. Okay, so we have 1 over square root 3 over 2. Okay, next one. Sine. Okay, this one is in 5 pi over 4, down here, quadrant 3, pi plus theta. Okay, so this is the sine of pi plus pi over 4. Okay, plus I'm just going to write this. There are rules for 10, negative, and so on, but I think it's easier just to realize that negative 2 pi over 3 is in quadrant 3. Okay, so I can actually write this as, this is the same as pi plus. Okay, because negative 2 pi over 3 means this is 2 pi over 3, which means this is pi over 3. So it's the same as pi plus pi over 3. Okay, which is basically just taking this number here, this minus 2 pi over 3, and just adding 2 pi to it. Anyway, hope that makes sense. Okay, now, the first one, well, that's what we got before, 2 over square root 3 times. Okay, this one becomes, we drop the pi at the front, it's just sine of pi over 4. We're going to decide is it plus or minus. Quadrant 3, sine is negative. Okay, that's a negative. And this one, this is 1 over tangent of pi over 3. And is it plus or minus? Quadrant 3, 10 is plus. So that is a plus. Alright. So, we've now got to get numbers for these. Okay, so sine of pi over 4 is 1 over square root 2. So that is negative 1 over square root 2. Okay, that's special triangle. Plus tangent of pi over 3. Let's go back and look. Pi over 3 tangent opposite over adjacent. Right? That's square root 3 over 1. So we're looking at 1 over square root 3. So we've got, I've got 2 over square root 3 times 1 over this is just square root 2, negative square root 2, plus 1 over square root 3. So we get, okay, we get negative 2 square root 2 over square root 3 plus 1 over square root 3 equals, just combine that, 1 minus 2 square root 2 over square root 3. That is the exact value. Okie dokie. Okie dokie. Next one. Given that secant of x is square root 5 and x is, wow, between 90 and 360. Okay, this could be anywhere from here, quadrant 2, 3, or 4. Find exact values of these things. Let's see if we can narrow that quadrant down. Okay, so secant is positive. Well, secant is 1 over cos. Okay, which is positive. So that means that cos has to be, what do you think, positive or negative? I would say cos has to be positive. Cos is positive here and here. CA. So therefore, has to be quadrant 4. Okay, so it's actually 270 to 360. Okay, so we're in quadrant 4. So, cotangent of x. Okay, well, cotangent and secant. Let's see if these little identities we've got up here help at all. Sec and tan squared. Okay, and let's see, I've got tan squared plus 1 equals sec squared. Let's try that one. Tan squared x plus 1 equals secant squared x. Okay, so tan squared x plus 1 equals square root of 5, which is 5. Square root of 5 squared is 5. Tangent squared x equals 4. Tangent of x equals plus or minus 2. And the cotangent of x is 1 over that. Plus or minus 1 over 2. Okay, that was A. There's all different ways you could have done that. Anyway, that's just one. Oh, actually not finished yet. Cotangent plus or minus. Actually, we can narrow that down. Plus or minus. Narrow that down by looking at our quadrant. We're in quadrant 4. Tan is negative. So cotangent is negative. Okay, so we're actually negative a half because we're in quadrant 4. So that's A. Okay. Cosecant. For B, we're looking at cosecant. Let's look at our formulas we came up with, these identities. Cosecant. 1 plus cot squared equals cosecant squared. Okay, that was the other identity. 1 plus cotangent squared plus cotangent squared equals cosecant squared. So 1 plus, well, cot was a half. Cotangent is a half. So cotangent is, whoops, that should have been an x. So cotangent squared is a half squared, or a quarter. Equals cosecant squared. So 5 over 4 equals cosec squared of x. So cosec of x is square root of that, plus or minus. Okay, cosecant is 1 over sine, and sine is negative in quadrant 4. Okay, sine negative, so therefore this is negative in Q4. So that means that cosecant x is negative, and that could be simplified. I can take the square root of 4 on the bottom and make that a 2. Okay, that example's done. Okay, last one. Okay, a little bit more complicated. Okay, just from the last video, this thing on top here with the sine of an angle here is 90 degrees. Okay, this is not a pi or a 2 pi. This is a straight up and down. This is like pi over 2. Okay, so we've got to remember from the last one that when that number there that we're adding our angle to is like pi over 2, when it's straight up and down, the sign changes to cos. So this becomes cos, and we still have to determine what sign it is that it can be a plus or minus, and that's just based on this. Sine, this is quadrant 2, sine is positive, okay? Just looking at this here, this whole thing here, the sign of that is a positive number, and the sign of this is a positive number. So this is going to be, these are both going to be cos. Okay, and the bottom stays the same. Secant alpha and 1 plus secant alpha. Alright, so we'll just focus on this left side here for now. So the left side, now we'll make a common denominator. Okay, so we'll basically times, let's see, on the left, so this is going to be cos alpha times 1 plus secant alpha over 1 minus secant alpha 1 plus secant alpha. Okay, just times both sides by this 1 plus secant. Okay, over here, opposite 1 minus secant alpha over 1 minus secant alpha 1 plus secant alpha. Okay, so then that becomes cos plus cos sec over, if we multiply this out, this is 1 using that dots rule, 1 secant squared alpha, and just expanding out the top, minus, okay, I'm going to have to pause this because I'm going to have to make a second video because my 15-minute limit is up.